Welcome friends to my channel. Now in today's lecture I shall going to start a new portion, that is electricity and magnetism portion. The first chapter of today's lecture is magnetostatics. Okay, so this is the first chapter of magnetism portion, that is the magnetostatics. So today we will discuss about some basic term: magnetic field, magnetic induction field. Okay, now we all know that when a charge q moves with a velocity in a uniform magnetic field or magnetic induction field b, then you all know that the magnetic force acting on the charge carrier is this: if this equals to q into v cross b. Okay, so when a charge q moves with a velocity v in a uniform magnetic induction field b, you all know that this is the magnetic force acting on the charge carrier. Okay, here we assume that uniform magnetic field b. Okay, now if we take magnitude of this, then we all know F equals to qvb by sin theta. Okay, so from which we can easily write b, this equals to f by qv sin theta. Okay, now if we simplify it by assuming that q is 1, v is 1 and theta is 90 degree, then we can write b equals to f. Okay, so from this we can easily define the magnetic induction field. Okay, so this formula helps us to define b. So what is it? It is the force acting on a unit charge which is moving with a unit velocity perpendicular to the direction of the field. So this is how we can define the magnetic induction field. Okay, that is the force acting on a unit charge moving with a unit velocity at right angles to the direction of force. So this is how we define b. Okay, so b is called the magnetic induction field. Okay, so it's, if we take its unit, so SI unit is Tesla or Weber per meter square. The SI unit of b is Tesla, so or Weber per meter square. Okay, now here the force is 1 Newton. Okay, and the charge is 1 coulomb, which is moving with a velocity 1 meter per second at right angles to the direction of the field. Okay, so when 1 Newton force acts on a charge of 1 coulomb which is moving with a velocity 1 meter per second at right angles to the direction of the field, then the field strength is called 1 Tesla or Weber per meter square. Okay, and its CGS unit is Gauss, or we can say there is another name, Maxwell per square centimeter. Okay, so like this, so what will be the corresponding quantities? Here the force is obviously 1 dyne and the charge is 1 AB coulomb or stat coulomb. Okay, the charge is 1 AB coulomb. Okay, that is moving with a velocity 1 centimeter per second at right angles to the direction of the field. Okay, So when the force is one dyne that acts on a charge of 1 coulomb, that is moving with a velocity 1 centimeter per second at right angles to the field is called 1 Gauss or Maxwell per square centimeter. Okay, now there is a relation between them, you all know it. So we can write 1 Tesla, this is 1 Newton by 1 Coulomb into 1 meter per second. Okay, so 1 Newton we can write 10 to the power 5 dyne, and 1 Coulomb means 1 by 10 AB Coulomb, and 1 meter means 10 square centimeter per second. So we can write is 10 to the power 4 Gauss. Okay, so this is the relation between them. So dear guys, this is up to this. Now in my today is the basic introduction, and in my next lecture I will going to discuss few other issues. Okay, thank you.